looking at this question, you can see that this is an exam question. It was practically an exam question. Now, from what we were given here, we were asked that the space between two plates is what? 5 millimeter apart. And that plate is filled with what? An engine oil of what? 0.9 what? Specific gravity. So you can see that this place is your place, is the space where your oil is being filled, and the distance from your fixed plate to your moving plate is what? 5 millimeter. Are we together? Now, you are also given a hint of what? You are asked that shear stress is equal to what? Dynamic viscosity plus what? Velocity multiplied by what? Velocity gradient. Now remember, this is your rule for what? Newtonian fluid. Newtonian fluid. So if you've gone through the videos for Newtonian fluid, your non-Newtonian fluid, you should be familiar with what? This equation. Are we together? So from this equation, you can make your U here, which is dynamic viscosity, to stand alone by dividing both sides by your what? Your velocity what? Gradient. Are we together? Now, from what we have here, let's bring out our data sheet. From our question, we'll simply have our data. The first thing we have there is for you to consider the distance of your fixed plate and your what? Moving plate. The distance here is what? 5, right? So we're giving 5 millimeter. So you are to convert that 5 millimeter to what? Meter. So you have dy here, and dy is given to be 5 millimeter. So you convert this 5 times what? 10 raised to the power of minus 3 meter. So this is in what? Meter. Now the next thing you are to consider is your moving plate and your what? Your fixed plate. From your moving plate, you have that your moving plate is having a velocity of what? You have your moving plate to have a velocity of what? 0.8. So what you have here is a force of 30 Newton is required to what? To a stationary, that's a force of what? 0.8. A force of 30 Newton is required to drag the upper plate to a constant speed of what? 0.8 meter per second. Now, that force that was required is to move this your plate to this side. You can see that they are pulling your plate. So if you are pulling this plate to this side, you have that the velocity of this plate, which is u moving, will be equal to what? 0.8 meter per what? Second. We know that our uf here, which is our fixed velocity, will be what? 0 meter per what? Second. Are we together? Now, if you have this to be your velocities for your moving and your what? Your fixed, what will be your du? Remember, your du from our previous example, know that du is what? U of what? M minus what? U of f, where u of m is given to be what? 0.8 minus what? 0. So you have that du is what? 0.8 meter per what? Second. Are we together? Now, what's the next thing you have to consider? The next thing you have to consider is, from your question, you were given what? Force. And we are given that the force is what? 30 Newton. So you impute your force into your equation. You have force of what? 30 Newton, right? Now, what is the next thing you are also given? From your question, you are also given that you have the area of the upper plate is what? 0.09 meter square. So you are given area. So you have your area here, which is A, is what? 0.09 meter square. Now, from what we have here, recall that we know that tau is equal to what? Force over what? Area. So we have 30 divided by what? 0.9. 0.09. Now, if you punch that on your calculator, you will simply arrive at what? 333.3 Newton per what? Meter square. So you've gotten the shear stress, you've gotten the value for your what? Shear stress. Now, what's remaining is, remember that we have from our hint that was given to us, recall that from the hint that was given to us, we have that, recall, you tell your examiner, from the hint that was given to us, we have that tau is equal to what? U du over what? Dy. So from here, we can get what is what? U, right? Now, getting what is u, we know that u will be equal to what? Tau divided by what? Du divided by what? Dy. Are we together? So what you simply do is you impute your values into your given formula for your dynamic viscosity, and you get your what? Your answer. Are we together? Now remember that your dynamic viscosity here will be what? U, and U will be equal to what? 3 3 you have 333.3, right? Newton per meter square divided by, now we are dividing this with what? 0.8, and 0.8 you are dividing 0.8 with what? 5 times 10 raised to the power of what? Minus 3. Now if you do that, you simply have that your U will be equal to what? 2.0831 Newton seconds per what? Meter square. Are we together? Now look at your question. Remember that you are asked that leave your answer in what? Poise. Your answer in what? Newton seconds per meter square and poise. So since we've already gotten our answer in what? We've already gotten our answer here to be in what? Newton seconds per meter square. What you do is you convert your Newton seconds per meter square to poise. So convert your Newton seconds per meter square to poise and drop it on the comment section. Let me see if you are following. Now, from what we have here, we can go further and calculate for your dynamic what? We can calculate for your kinematic viscosity, because we've already calculated for your dynamic viscosity. So if you want to calculate for your kinematic viscosity, we'll simply have that your kinematic viscosity will be equal to what? Dynamic viscosity divided by what? Your velocity, your density, right? So we have kinematic viscosity is dynamic viscosity divided by what? Density. Now remember, you were asked that the density, the fluid that was given to you is what? Oil. Go back to your question. You were given the fluid here to be in what? That the fluid was what? Oil, right? That was what they said. Crude oil. So since we have the fluid to be crude oil, our interest will be what we have here to be the specific gravity. Are we together? Now recall that we know that we are given specific gravity, and we said the specific gravity is here is what? 0.9. Are we together? So what do? What should come to your mind is specific gravity is equal to what? Density of oil divided by what? Specific what? Weight of water. This was the equation we proved earlier from the what? Properties of what? Fluid. Now we know that we are given what? Specific gravity, and we know that specific gravity is what? 0.9, and this will be equal to density of oil, which we don't know, but we know that the specific weight of water is what? 1000. So we have this to be what? 1000 kilogram per what? Meter square. So what you simply do is you cross multiply from what we have here. If you cross multiply, you have your density of oil. You simply have your density of oil, which is rho of what? Subscript R, will be equal to 0.9 multiplied by what? 1000. And you simply arrive at what? 900 kilogram per what? Meter square. So if you succeeded in getting the density of oil, you can impute the density of oil here into the equation for your kinematic viscosity. And if you do that, you simply have that your kinematic viscosity will be equal to what? 2.0831 Newton seconds per meter square divided by what? 900 kilogram per what? Meter square. So what do you simply have? You simply have this to be what? If you punch your calculator, you simply have the value for your kinematic viscosity to be what? 2.3146 times what? 10 raised to the power of what? Minus 3 meter square per what? Second. So this will be the value for your kinematic what? Viscosity. But from your question, we were asked to leave our kinematic viscosity to be in what? Strokes. After getting your answer as meter square per second, leave your answer in strokes. Now for you to convert your meter square per second to stroke, you recall that when we are considering strokes, we say that one strokes is equivalent to what? 10 raised to the power of minus 4 meter square per what? Second, right? So for you to get your kinematic viscosity to be in strokes, we'll simply have this to be 2.3146 times 10 raised to the power of what? Minus 3 meter square per what second multiplied by what strokes, and this will be divided by what 10 raised to the power of what minus 4 meter square per what second. So you can see that you can cancel out this and you're left with what just strokes. So what you simply do on a calculator, you simply punch 2.3146 times 10 raised to the power of what minus 3, divide that with what 10 raised to the power of minus 4, and you simply get the value for your kinematic viscosity to be what 23.146 what strokes. So you've succeeded in calculating your answers to be in what poise and in what strokes. Don't forget to drop your answer for your poise on the comment section. Do that now. Thank you very much and see you in my next live class.